All right, 1:02 p.m. We will get started here, and some others may be joining us a little bit later. I would like to start by introducing myself, Kristen Foster, the Otter Tail County Engineer, and I am based in Fergus Falls, Minnesota. And I'm happy to be here today as Vice Chair for the CTS Transportation Infrastructure Research Council to share a little bit more about the background of our councils. The CTS councils provide a forum for transportation professionals and researchers to exchange information on current transportation issues and trends. They bring together university faculty and staff with practitioners from the public and private sectors to recommend direction and participate in improving the center's research, education, and engagement programs. Sam will share a link to the council's information in the chat shortly. And today's webinar features a presentation on the effect of tree shade on winter maintenance operations. I will share a little bit more about this in a moment, but first I'd like to go through some housekeeping things for you. Next slide, please. We are looking forward to audience participation and questions during Q&A time, which will follow the presentation. We encourage you to use the Q&A at the bottom of your screen anytime to type questions or comments for the speakers, and we will be monitoring them throughout the presentation. During the Q&A session at the end, you could use your raise hand feature if you prefer, and then we could unmute you to share verbally, or you can continue to type questions through the chat box. Today's event meets the continuing education requirements for 1.5 professional development hours for engineers, as well as 1.5 AICP certification maintenance credits. If you need a PDH form, please send a chat message to the panelists with your name and email. We will email the form to you following today's event. CTS hosts a variety of transportation research webinars during the spring that you might be interested in. Our next webinars are on the pedestrian safety and driver behavior near automated vehicles. That one is coming up on April 30th at 1 p.m., as well as a freight and roundabouts meeting on May 22nd. To hear more about upcoming seminars or view past seminars, please visit the CTS website at www.cts.umn.edu/events/seminars. Finally, if there are any students joining today, please send a chat with your name. We do track the number of students who are engaging in our events. Thank you very much. And before we get started with today's presentation, I would like to turn it over to Chair Beth Ingham to introduce the presentation and speakers.
Thank you for covering me, Kristen, during my technical difficulties. Welcome, everybody. I'd like to just add that we have Sam Han-Duville and James DeSoto from CTS on this call, which they're supporting this event and making things easy for Kristen and I to provide you this information. So here we go with the webinar. This webinar highlights a U of M research project that's evaluating the effects of shade tree on pavement temperature during Minnesota's winter months. The research team is working with MnDOT to better understand the balance of optimal sun exposure, tree cutting, and winter maintenance activities on State Highway 34, which is a paving project between Detroit Lakes and Osage. So MnDOT was initially interested in cutting down the shade trees along the corridor to maximize sun penetration on the roadway. Exposing the pavement to more sunlight obviously helps melt off snow and ice, which lessens the need for de-icing agents and then reduces the chloride runoff to nearby water bodies. As a result of public interest in preserving the trees, which we all know is a thing, MnDOT removed fewer of them than originally planned. So I'd like to welcome today's speakers. We have a couple. We've got Tom Lundberg. He's the Assistant District Engineer in Program Development for MnDOT District 4. And Mihai Maristostenau is a CTS scholar and professor in the Department of Civil, Environmental, and Geoengineering at the University of Minnesota. Xu Feng is the assistant professor in the Civil Department, Civil Environmental and Geoengineering Department. And we also have engineering student Stanley Guerrier here to join us. So I'm going to turn it over to Tom.
All right, thank you. I'm gonna try and share my screen here and get done with the difficult portion of stuff here, hopefully. So can you see my presentation starting out okay now?
Yep.
Awesome, that's a good sign there. We're starting on a good foot here. So, well, I'm excited kind of to discuss some of the stuff we're finding out here as was discussed or led into the presentation here. I normally do road and bridge projects, and a shade study is not something that I thought I'd ever be doing here. So this has been kind of a nice little sidebar to the stuff that I would normally do in our operations out of Detroit Lakes. I would like to know that Cole Scalene is with us here as well. He's our maintenance supervisor, maintenance manager in the district. It's a little bit closer to the snow and ice operations. So if we get into some questions, and you hear Cole on, that's why he's here, because that's in his wheelhouse more so than mine. And in general, for my part, I'm going to talk about the background that kind of got us to this study and just a little bit of the high level things for about the first 10 minutes. And then I'm going to pass it on to Mihai and his staff to kind of get into the fun details that we've been working on for the past little bit there. So what started us out here was we were working on a paving project. It actually took place in 2023. And the area that we were looking at was roughly 10 to 30 miles east of Detroit Lakes. And you can kind of see, this is kind of a corridor picture of kind of what it looks like in general out there. And so you can see lots of trees. There's a mix of pines and hardwoods out there and things like that. So it's a nice corridor that we have east of Detroit Lakes. You know, lakes and trees are why people come here. Drilling down a little bit closer into this corridor here, the set back of the two deals here is the westerly side of the project, and it's more a mixture of trees and open areas, some lakes and swamps and stuff. And the area that we're really concentrating on was the easterly 7 miles of the corridor from the town of Snellman, which is kind of pretty small. It's a couple homes that's left there. And then just before Osage, it's 7 miles there. It goes to the Smoky Hills State Forest. It's very wooded and a very picturesque drive there. So that's where a lot of the stuff that we're looking at talking about today is coming from. So with this 2023 paving project, we're looking at it, and excuse me, the trees and things were getting closer and closer to our roadway. We hadn't really beat back the brush a lot, and we're looking at cutting the trees back to at least their clear zone plus 10 feet or so to manage our right of way. And then we got a lot of right of way beyond that, so we're looking at really thinning out most of the trees, more looking at almost like logging and leaving just a little bit left there as we're leading into our project. So just to let you know, out in this area there, it's a little bit of a different corridor than we'd normally have for a 2-lane rural highway. We have roughly 250 to 300 feet of right of way per side, which is really not, like I said, something that you'd normally see in one of these settings here. The reason for that, back in the late 60s, early 70s, MnDOT at that time was planning for a dual lane divided highway out here. And I think that was back when we maybe had a lot more money and we're really trying to really build things out. And so we were going to do that, and we had purchased all but 5 parcels out here that were going to go to condemnation. And then at that time, the project got canceled. So we've got this 2-lane highway out in a rural area with tons and tons of right of way. So it's not your typical section, and that's part of the rationale with, you know, the trees and different things that we're going to talk about here. So as we're getting into this project, and with every project, we scope it. Each of our functional areas weighs in on different things that probably should be considered with the project. And our maintenance staff was looking at this going, gosh, we spend a lot of extra time and effort out, especially in the shaded area in the Smoky Hills. We put more product down on the road. We have slower recovery times to bare pavement. We got trees falling on the road. We have special trips that we have to take out here just to kind of touch this section up. And so they're looking at this going, hey, we'd really like to cut back a lot out here. So like I said, we were planning on cutting back the clear zone out along the highway, and then those extra extents trying to log it more, like managing a forest and things like that. So you can kind of see in this picture, this is one of the more shaded areas that we have. You can see during the day here, there's no sun really hitting in the winter months because the sun angle is so low. So that's some of the stuff that we're dealing with, and it kind of gives you an idea of some of the more shaded sections of the corridor. So with that, with any project, we start to talk with people and tell them what we're doing, and got this out to the public, and they really weren't having any part of it. They really did not want to see any trees cut out here. They would rather that we sacrifice safety with trees falling on the road, have poor level of service, and just preserve what we have out there, not do anything out on the roadways. So there's the beauty aspect to it, lady slippers, it's on a scenic byway, and so they really wanted to see this area preserved. And we went back and forth quite a bit on that, but we decided on the safety end of things that we're definitely going to cut the clear zone plus about 10 feet to kind of beat back the brush, if you will, in there. And we agreed that we'd follow up with a shade study that kind of got us to where we are today. So that's kind of some of the things that led to where we're going. And this picture kind of just shows a little bit of what we're doing for the cutting when we did the project back in 2023. So the red line kind of just follows the tree trunks that are of the trees, and you can see the solid green area is more of the canopy, but it shows just how little bit we kind of cut along there. And then you can kind of see some of the shade trees hitting the roadway in this area here. So you can kind of see some of the shade issues that we're dealing with. This picture kind of shows a different way of showing just the little tidbits of areas that we cut to maintain the clear zone plus 10 feet. And so we did sporadic cuts through the corridor to push back the encroaching vegetation, and we tried to stay out of swamps when we were doing that. But also this kind of shows you the heavily forested area we're dealing with. There aren't a lot of homes in this area, and so you can kind of see the beauty portion of it, that the environmental end of things those people were kind of pushing for. And this picture is looking west towards Detroit Lakes, just kind of for some reference. Then drilling into things a little bit more, this picture kind of shows the wideness of the right-of-way that we have out there. So the red dotted line on here on each sides of the roadway shows our right-of-way. So we have a lot of space out there. We have a lot of trees and different things. And so you can kind of see the breadth of what we're dealing with. You can see the shade. This picture, I think, was taken in the springtime, but you can still see the shade out on the roadway in some of these areas and some of the stuff we're dealing with there. The pink circles are our wetlands. And so it was brought up earlier in the introduction about chlorides. So our snow and ice effort has chlorides associated with it, with the salting and sanding and stuff there. So that's also a concern that we have when we're doing these things. So with this, volunteering up a study, we started to look for places or people that could help us. And the U of M, obviously, with the research end of things, was kind of high on the list of places or people to work with. So we worked with the U of M to get this study going. And we actually started 2 winters ago and went through this last winter, which brought us up kind of to today. And I'd like to say we started on the ground running, but we really didn't that first winter. We were working with sensor issues, cameras out there, different types of data collection that we were doing. And we really were kind of just getting things going and figuring things out more 2 winters ago. Sorry here. Should have shut my phone off. And so 2 winters ago was kind of tough. This past winter here, we got into the details and started to work our bugs out with the different data sets that we're collecting and things we were doing. So I felt like we were getting more our feet underneath us and gaining some traction. And the U of M staff's going to go into a lot of the details of the stuff, so I'm not going to cover all the different things that we're getting into. But the one big one that we got this last winter that was huge was we were able to get a data collection device into our snowplow that was out on this corridor. So in the past, we'd load the plow up and they'd go down the road, and they might go on Highway 34 and they might do touch-ups somewhere else. And it was really hard to track what they did where and how much was being used. And so with our data collection device that we have in the plow now, we can see where it is, its speed, temperatures, XY locations, pounds per mile that it's putting down in different areas. And so we can start to equate time and effort and costs to different parts of the roadway, which has been really neat to see. It'll also help us if we do specific trips out to, let's say, this area to touch up on things there that we kind of know and can equate that that's a special trip to just this area. So that's been a huge thing that we got this last winter. But at the end of the day, you know, when we're looking through all this data that we're going to talk about, you know, we're looking for what might make sense for if tree cutting is needed or not. And, you know, with the limited data we've had these last 2 winters, we're looking at actually doing this one more winter here. So this might be a little bit of a teaser to the group, because we'll have some more here in the future. We're constantly learning and growing as we go. So there's some rabbit holes, I think, that we still may go down with this. And then we'll look for potentially something in the summer of 2026. So with this, like I said, we're looking for the results at the end of all this, whether we cut a whole bunch more, we limb some trees, we selectively cut some stuff, or maybe we do nothing. And just to give you a pictorial here, this is a sun angle in March in the year. And so if you wanted to get rid of the shade off the roadway, everything kind of above that yellow line there, potentially would either have to be cut or limbed or something like that. So you can kind of see what the shade is doing to the roadway. And then at the end of the day, you know, we'd all love it if we can limit the use of these behemoths that we have down the roadway with the time and the effort, the materials and things like that. And, you know, if we can limit that, that saves a lot of money, resources, impacts the environment with the chlorides and things like that. So there's the things that the practitioners and us are looking at, but on the environmental side, they're also concerned about the aesthetic value, the value of the trees, and the beauty of the corridor, the commerce that flows through it, and things like that. So those are some of the things that we'll be struggling with here as we move forward with some of the stuff as well. So with that, I'm going to quit talking here, and I'm going to let Mihai and his staff jump in on some of the fun details that we've gotten into with the data collection and the techie portion of this stuff there.
Oh, thank you, Tom. Let me share my screen right now. I think it's this one. Can you see it okay?
Yep.
All right. So first of all, I would like to thank the CTS Infrastructure Research Council for allowing us to present this very interesting work. I have to mention that actually CTS played a critical role because they put us in contact, the 2 parties, Tom and his group and our research group here. We had a lot of fun together. I have to say we had many meetings and we really enjoyed working with Tom and Cole and their colleagues. Very, very interesting project, very challenging also. I would like to, before I start, to acknowledge our research team. So my colleague, Associate Professor Shui Feng, who is also a McKnight Land Grant professor at the university. Our very talented undergraduate student who did a lot of graduate level work in this project, Stanley Guerrier. Our very, very talented research scientist, Mogor Turosh, who participated in all the activities of this project. And our former student, Naomi Alizarov, you see he has a star, definitely a star student, but he graduated and he's happily employed a structural engineer right now, but he did some of the initial modeling and for this project. And as Tom described, this is actually the study area. I just want to mention that this particular road kind of goes east to west, which in a way made it easier with some of the shade analysis because of obvious reasons. But this analysis can be done with on any other type of road orientation. And as Tom mentioned, basically we're trying to figure out what is the impact of the shade, tree shade on pavement temperature that is then related to the amount of salt or other de-icing chemicals that are placed on the pavement. So obviously a safety issue, you don't want to have any skid problems, and also an environmental issue. And basically, Tom asked us, can you quantify this temperature disparity? I mean, we could see it. I think we can all see in winter shade versus full sun areas, and you see a big difference. So then we got to work, and the first thing that we wanted to do is to collect some data, use that data in a heat transfer model that would allow us to make predictions for various temperature regimes in winter, and include a shade factor that has not been evaluated before. I mean, there are some limited research on the effect of shade on temperature, mostly for hydrologic design on rivers, but not on pavement. So as far as I know, this is, I guess, the first one that looks at the effect of tree shade on pavement temperature. And based on this shade factor analysis, give Tom and his team enough information so they could optimize possible tree removal activities. As we mentioned before, we are all for trees and shade, but there are some particular situations where maybe there is a need to do some removal. And of course, we started with a data collection. And I'm showing here a picture of a very fancy device that our colleagues at MnDOT have. The one in the back here is a road doctor. And we were very fortunate to have them come and collect the data using what is called the road doctor survey band. That does all sorts of, collects all sorts of interesting information, including ground penetration radar. But for our particular case, we used their infrared camera. They have a very powerful infrared camera that can scan the entire pavement surface at traffic speed and generate a lot of data. So, and we were able to get some information in February 2023. So yeah, we started working on this 2 years ago. Lots of useful information. You can see here images of the thermal images. You see here a morning and afternoon, the pavement surface. Of course, it's color coded, so you can see better the temperature differentials. The blue, dark blue, it's colder, and obviously the green and the reds are warmer. There was one run in each lane in the morning, eastbound and westbound, and then was another run in the eastbound in the afternoon to compare what the pavement temperature was. And this is what the data looks like. And before I say anything, I would really like to thank our colleagues at the Office of Materials and Road Research, Thomas, Calhoun, and Eyoab. And they were instrumental in running the test and providing us this information. And of course, you see a lot of numbers here. These are data points on a line. So we basically, they generated hundreds of thousands of data points that we then processed and performed some analysis. So this is what it looks like. So this is, for example, the eastbound heat map sample in the morning and in the afternoon. So all these colors here represent hundreds of thousands of data points that were converted using the specialized software in these colors. Some pictures, the full sun area looked like that during that day. The full shade area, as you can see here. And what we did first, we processed the data. We tried to look at the temperature profile for the locations that were in the sun and locations that were in full shade, and look at the difference. And this is obviously, we had, as I said, lots of data points, and you can see a frequency versus temperature. This is in degrees Celsius. So you can see here the distribution of the temperatures. And if you look at average values, you can see that in the sunny portion, these are the morning and afternoon temperatures. So the minimum and the maximum, clearly a difference between morning and afternoon. On the average, morning was -8 degrees Celsius, and the afternoon was 2 degrees. So clearly a big impact of solar radiation here. In the shade, as expected, obviously much lower temperatures in the morning, -15. And then it went to -12. The max was -12, so not a very large maximum value. And you can see also that because the sun did not have the same effect, you can see just a smaller increase in the afternoon temperatures. So these were the initial results. Again, it was just 1 day data for 1 day. However, that was very, very good, very useful data. So the shaded area is around 6 degrees Celsius or 10F colder than the sunny areas in the morning. The shaded area is around 10 degrees colder than the sunny area in the afternoon. So again, because the sun cannot do a lot. And always the full sun surface temperature was higher. So we basically proved what we sort of all know what happened, so that basically the full sun area were much warmer. And we also found out that the temperature differential between full sun and full shade increases with colder weather. And at that time, we were starting to think maybe do some partial cutting. I mean, we were just starting to think about it. But of course, this was just one data point, so to speak, one big data point in 1 day. Then, of course, we started to think, what's happening when, you know, if we are to measure in a different time of the year. And the solar position obviously is very, very important. It has a direct influence on the tree shade length. And to better understand this effect, we actually used a very nice tool. Actually, Tom and his team told us about it. SunCalc, it's a free piece of software that actually does exactly this, gives you the shadow length for any specific location and time of year. So you just need a specific location. And of course, if you want the shade, the length, you need how tall the tree is. This is what it looks like. It is an animation. I'm not going to run an animation because it consumes a lot of data, but you can see in this particular case, when the sun was directly south here, the black line that you see here was the length of the shade. And you can make calculations. And just to give you an idea, for a tree of 15 meters height, you can see that obviously in December, when it is darkest and the angle of the sun is lowest, you get very large shade from a 50-meter tree, so it gets as high as 70 meters. And as you move slowly into February, this drops down to 40. So this is something that at some point MnDOT should consider when you do the optimization. What are you trying to do? Do you want to remove shade completely all year long, or are you trying to limit, maybe reduce shade in the months when it's the coldest, like January, February, where the shade length is smaller? This was all great. Well, we got to play with some exciting data, but of course the issue is we couldn't bring the road doctor there every time. So, and it was a great idea, and I'm very happy that they were able to do so. Our colleagues in District 4, actually, they purchased some sophisticated temperature sensors that then they embedded the sensors in various locations on Highway 34 that cover full sun, full shade, and some intermediate areas also. And this is the example that you can see here of the sensor, measures road temperature at the surface at 2.4 inches and 1 foot below in the structure of the pavement. And we got very excited because now we had continuous measurements. Some pictures of where these Vaisala ground gas sensors were placed. The team also had cameras installed so you could see if it was snow or rain or whatever. So all of this information was available to us. Lots of information. Luckily, we had the right people to deal with all this information. Stanley and Mober did a great job working with this. And we also had access to additional data. It was not in exactly the same location, but it's in a weather station not too far that provides, as part of the web MDSS, air temperature, shortwave radiation, precipitation, and so on. So we had all this data available to us. Looking at what these sensors could generate, you can see air temperature, the shade temperature, the full sun, different colors here. We also included the shortwave radiation from web MDSS. And you can see immediately that there are some differences between air temperature and the shade and full sun. So this is January 2024. And yeah, surprisingly, temperatures 20, 30 degrees. So really not a great winter for our research, maybe great winter for other things, but not for our research. And more data just to show you what it looked like with shade and full sun and air temperature, January 2024. And we continued the project. So we obviously collected this winter as well. We got some colder days, not a lot of snow. We hoped also for some snow to see the effect of snowpack. But again, you can see here, obviously, full sun, pavement surface temperature much higher than the full shade surface temperature as expected. And these are some averages just to have an idea. Of course, now I have to mention the average is for 24 hours. So it's not just when the sun is out. So that's why you see that some of the differences are not as large as expected, but they are still different, which tells you that the effect of solar radiation also continues, during the night times and so on with respect to pavement temperature. And a key component of this was the development of the heat transfer model. The initial model we developed using Minro data from 2016. Naum Yelizarov started working on that, and then Stanley stepped in, and when Naum graduated, and he continued the work. So the original work did not have a shade factor, but we were able to include a shade factor in the next iteration. So Stanley, if you want to discuss the heat transfer model.
All right, thank you, Dr. Matsanu. As you just mentioned, I will be focused on the heat transfer model, which was initially developed using Minro data from 2015. This model aimed to simulate the thermal behavior of the pavement structure. And it's important, like you just mentioned, this model does not include the shade factor, but we will include the shade factor later in the presentation. For the numerical implementation, we use the MATLAB partial differential equation solver, also known as PDEPE. This solver is particularly effective for solving parabolic and elliptic partial differential equation on spatial variable in time. We also use an explicit finite difference volume approach, which discretize the domain into small volume and apply the finite difference method approximate to the derivative. And additionally, we use the Kirk-Nicholson method, which is a time-stepping scheme that is implicit in nature. This method is known for its stability and accuracy, as it averages the value at the current and next time next time step. It's required 2 to 3 iterations to achieve convergence at first layers and before calculate the remaining layers, ensuring that the solution is stable and accurate. The governing equation for our model is derived from the heat conduction equation and that is shown here. This equation describes the rate of change of temperature within the pavement material as a function of its thermal properties and partial gradient of temperature. Next slide. For the model to work, we have to set the boundary condition at the top and bottom pavement. At the top boundary, we consider the pavement surface energy balance, which is shown here. This component of the equation represent the various energy exchange occur at the pavement surface. And at the bottom boundary, we assume the flux is 0, which simplify the equation. This assumption implies that there is no flux at the bottom, which is reasonable only to approximate like deep pavement layers. The stability condition for the PDEPE and finite difference method is has to meet the boundary conditions, the stability condition shown here. But this condition ensure that the numerical solution remain stable and does not exhibit on physical oscillation. And it was worth mentioning that the Nicholson method is unconditionally stable, meaning that it remains stable for any time step size, which is significant advantage for long-term simulation. For the thermal property input parameter, in our case, we use asphalt thermal property, and these values were chosen based on typical range for asphalt material and are critical to accurately modeling the heat transfer within the pavement. Here is the result of the first model, method like PDEPE. As you can see the model capture the sensor temperature profile pretty well. Next, and the next one is using finite difference volume. Similarly, you see like the model work pretty well. And the next one is the Nicholson method. This one is like kind of like show like a less error and more accurate, but it takes like more time to implement the model. Okay, now we get new data and we want to incorporate the shade factor. And we estimate the shade factor using the measure data from WebMDSS as previously mentioned. And then the full sun sensors, full shade sensors. These sensors like provide like comprehensive data on the shading effect of different type of tree and pavement conditions. We incorporate the shade factor into the net shock radiation. This is the equation of net shock radiation shown here. And the shade factor is ranged from 0 to 1, where 0 means no tree shade effect, and 1 means all solar flex is blocked by tree shade. This adjustment allows us to account for impact of shading on the pavement temperature. We first optimize the model to determine the pavement thermal property because we don't know like the exact pavement property. We have to optimize the model to find this value. And then we optimize the model to obtain the value of the shade factor. For the data collected in winter 2024-2025, we optimize the optimization result in the shade factor in the full sun is like for the shade factor is 0 as we expected. But for the full shade, we get like a shade factor approximately 0.5, meaning that like the trees is reduced the incoming solar radiation by 50%. We validated the model by first predicting the temperature at the surface and at 6 centimeters below surface. And then we calculate the mean square error between the model and the measure data. A lower RMSE indicate like a better fit of the model to the data. And then we calculate the R square, which is measure the proportion of variance in the measure data explained by the model. A higher R square value indicate a better fit. And then we plot like a best fit regression line to visualize the relationship between the predicted and measured temperature. And finally, we plot a one-to-one reference line to show how close the model prediction is to the measured data. The closer the points are to the one-to-one line, the more accurate the model is. Here is the result of our model, including the shade factor. The top left figure is the predicted data against the measured data at the surface, and the one in the bottom left is the measured data against predicted at 6 centimeters below surface. As you can see, the model captured the temperature profile really well, and there's like not much error in the model. And as you can see in the right figure, you can see like the data is well kind of like center, like close to the reference line, showing that like there's like less error. And then this is like the model for the full shade with like 50% shade factor. And as you can see, this is on the left top. This is the prediction at the surface, and the bottom left is the prediction at 6 centimeters below the surface. I'm gonna pass it over to Professor Shuefeng to continue with the shade factor.
Okay, thank you, Stanley. So the results that Stanley showed earlier were using shade factor calibrated across the entire data period. But what we also wanted to show is segment the data into specific shorter periods and see how the shade factor would vary across time. And so this is the plot that shows the effect of the calibrated shade factor estimated over time. And you can see from this plot several interesting results. One is that the shade factor will increase with the type of trees, meaning that, for example, in the full sun pavement cases, you can see that our inferred number for the shade factor are close to 0. So these are the points shown in green on the bottom and in purple. They're very close to 0 because, of course, there's no shade inhibiting the sun from reaching the pavement. However, in the blue, the orange, and the yellow lines, we see an increasing value for the shade factor corresponding to deciduous tree in blue, a mixed deciduous and coniferous tree type in orange, and then finally a more coniferous type of trees that retain their leaves in the winter in yellow. And so this means that our shade factor is sensitive to differences in the functional type of trees, whether they are dropping their leaves in the winter or not, as well as the difference between having trees there and not having trees there in the full sun. Another interesting thing to note is the fact that when the shade factor is above 0, when there are trees, its value will actually decrease over time for all of the tree types in yellow, orange, and blue. And this is due to the effect of increasing sun angle as we extend later into the year. And so you can see that the effect of shading on the pavement can be most pronounced during the winter time, and diminishing toward April and May and June later in the year, because now the sun is fairly high up and the difference between having shade or not having shade on pavement temperature becomes minimal. Okay, next slide. Oh, so I think the first 2 bullet points basically summarizes what I said earlier about the fact that the shade factor in our model can differentiate between the different tree types, and also that it will decrease over the year as the sun angle increases. And these results are derived only using a limited amount of data that was available to us in 2024. And most of it was recorded when the temperature was above freezing, because we had a pretty mild winter time. And so what we hope could be done is to extend this analysis into more periods when we have variable wintertime temperatures, and especially for when the temperature is much, much lower than the freezing point, so we can get a better picture of what the shade factor is doing in this model. Next. In addition to that, we hope to connect this parameter for the shade factor in the model to specific tree measurements that we can take on the road, right? And so these tree configurations can correspond to things like how high the canopy is, how far is the canopy from the pavement itself, and also to think about how we can leverage these type of information and data to also evaluate not only the impact of shade during the summertime, but potentially during really hot, extreme summer days too, when actually having shade would come at a benefit for reducing pavement temperature and potentially increase pavement durability. To connect the shade factor to physical characteristics of the trees that we can measure, we can take advantage of existing LiDAR data, like the photos that you see on the bottom there, which can kind of extract information about, for example, the tallest trees near the roadway on the left, and then and the trees that have close limbs to the road as well. Next slide. And then here are just a few more pictures for what those data from LiDAR information can tell us. And so, for example, a view of the trees from the roadway, looking in different directions, as well as on the bottom, kind of a transect of where those trees might intersect the sun angle, so that we can be very selective about identifying the parts of the tree that are doing the most for shading. All right. I think I'll pass it back to Mihai now.
Thank you, Shweta. As Tom mentioned, we were able to get additional data. We are very excited about this possibility, because now we could relate the presence of shade with and the effect on temperature with material usage. And I would like to, I know Tom and his colleagues, they spend a lot of time trying to figure this one out, and this was excellent work that they've done. And now we have this capability of looking at material usage. We just started to look at it, so I'm just going to show some preliminary data, and hopefully next year, if the project will continue, we'll have much better information. But this was available from the Precise MRM website. As Tom mentioned, provides comprehensive details on application of granular materials and liquid brine along Highway 34. Granular materials are characterized into pure salt, a 50-50 salt sand mixture that has, it's called S5050, and then a 90-10 sand to salt ratio mixture, S9010, and also liquid brine. And we started to look at the data. This is preliminary, as I said, but this is the kind of plots that we can generate. And we are able to look, you know, they represent exactly the same date if you look when the data was collected. So this is for full sun, and you have different colors here. Salt is yellow and orange is S9010. Brine is the green one. And the same days data collection for the full shade. So full sun, full shade. Just by looking at the plots here, you can see that there is a clear difference. That in the full shade there is a lot more materials, chemicals used on the pavement. I asked Tom about this particular day where it appears to be the same, and he said that was a very, very nasty day with a lot of icing, so they just decided to basically spread S9010 for the end, so a larger portion of the pavement, just in case. So just by looking at this preliminary data, we actually were able to do some kind of simple calculations and found out that basically for the full shade pavement, to get rid of the ice and make the pavement safe, there was almost twice the amount of materials used compared to the full sun pavement. Also, if you look at the granular S9010, again, almost double the amount used compared to the full sun pavement. And also the same could be said about the brine. So very interesting data. We didn't have access to it before, but I think this is very, very, very useful. I think it's very useful for the winter maintenance operations as well, because just by looking at this data, they can actually optimize, you know, improve their operations. So this brings us to the end of this presentation. A few important conclusions. We were able to show that there is a significant temperature difference. So we have numbers. As I said, we all knew this was the case, but we really didn't have a sense of the magnitude of the temperature differential. And clearly, this has an impact on winter maintenance operations. So there is clearly an impact, shade versus full sun. We are able to develop a very robust heat transfer model, and we are very happy with that. And this model includes a shade factor. Obviously, we need now to relate the magnitude of the shade factor. What does it mean in terms of type of trees and tree configurations? Because this would be key to providing guidelines in terms of possible tree removals or partial cutting and things like that. We also think that the research and also the sensors that are still in the pavement would be very useful for continuation of this project, not just to winter maintenance operations, but also to look at the entire time of the year, address the hot temperatures in summer. We could expand this analysis to other locations in big cities, for example. So this is very useful initial data that, and also the capability of accessing the sensors 24/7. This is very, very important. So we hope that we will be able to continue this research. And I think this is my last slide. Just wanted to say that we are hoping for this. and we got what you see at the bottom. That's okay. Maybe next year we will get more snow and do more interesting research. And with this, I would like to thank you and open the floor to questions.
Thank you to all of our speakers. As a reminder, you can use the raise hand feature if you have questions at this time, or type your questions in the chat box, which we will be monitoring. And we'll get started with a couple of questions for our panelists. From Douglas, at any point did you directly measure solar radiation at surface? If so, how did that compare to the shade factor?
Would you like to answer that, Stanley? I mean, we didn't measure solar radiation. Stanley, would you like to answer that?
We didn't measure directly the solar radiation at surface, but we have like access to this data from like WebMDSS. So they have them from they have like it's a weather stations where they have like all this information.
Yeah, and I would add that there's a sensor, a road weather station about 2 miles away. So that's where we're getting that data for the solar radiation through WebMDSS.
Thank you, Stanley and Cole. Next question, for those who worked on the LiDAR aspect of this project, do you have any recommendations for using aerial LiDAR rather than truck-based LiDAR?
So I don't have my surveyors with us that provided a lot of that, but we got stuff from the road doctor van that we talked about, and then we did scans of the woods at the sensor locations. And we did do drone flights, but I don't believe we got LiDAR data out of that. But I could see that if we got more into conclusions of what we want to do for maybe partial cutting or some type of cutting, that you could maybe use a LiDAR flight to help guide or direct some of that cutting there. So we kind of got a good idea of the trees without having to go out and really do a lot. You know, maybe it'd be a fun thing to ask AI if it could optimize a tree cutting based on some criteria or something like that. But we really haven't done the LiDAR with the drone flight, but that could be a future thing. You know, it's a good idea if we do some more cutting to maybe look at that as an option.
Thanks, Tom. This one might be a question for Cole. Can you talk a little bit about the timing of plowing? Does the timing of plowing affect the ice buildup or the need for chemicals? And was that looked at as part of this study or a future study or another study?
I guess it wasn't specifically looked at, but we tracked the times that the plows went out, so that was all recorded. You know, we are a 24-hour operation, but this one being a little lower volume, it's cycle times. That's one issue that we have in Outstate is our routes are so long. So I think this route is about 80 some miles if you go start to finish. So you know, you can maybe only get across that route 3-4 times. So that is into consideration. That's kind of why we had those cameras out there to help us know, you know, when it was plowed, when it wasn't plowed.
All great questions. Do we have any other questions for today's presenters?
I know maybe Kristen, while people are thinking here of other questions, I could add just one thing. You know, we've been visiting with the locals that are interested in the environment and that type of thing. And there's a potential for the locals to ask for a grant or find funding to really look at the chlorides. And is there a difference in what is in the wetland complexes and things alongside the roadway, maybe more in the Smoky Hills where we're using more product versus other areas? I think we all have heard, you know, chlorides are bad. They stay in the aquatic system kind of forever, things like that. So that might be a neat thing. You know, I mentioned some rabbit holes we might go down coming into the future. That could be one of them that would be really neat to see, because I think we've heard of that type of stuff. And I know Cole and I talked beforehand, and I was asking, do we really know of any research out there or any of that type of stuff that we can get our paws on? So that's one thing that I think we might do. And you know, if there's others out there that kind of know of studies on that, I'd love to hear about them, because that's one thing I think it would be neat to see, is if we're using more product in some of these woodland areas, that is an environmental concern in itself there too. So that's something there. And I know we touched a little bit on some of this, but recovery times are a big one. You know, Cole talked about the long routes and the plow out there. So those might be some things that relate to safety and snow and ice buildup and things like that that we might look at a little bit closer here into the future. But there's a few other things, you know, every year we've been kind of learning as the study's been going. So, you know, we'll meet and kind of talk about some good ideas to go forth in this next season there if we can get Mihai and his staff on for another go around here. So
Tom, I got a question individually, just in a person couldn't get in through the chat on this, so they teams me, and it was, is there additional consideration towards traffic crash data, you know, before, after, to capture safety benefits of snow and ice removal? And we used it for the before a lot with the public. I can answer that part. I worked with traffic engineering. They were at all our open houses. We did have a fatal run off the road, hit a tree on this corridor in this exact location. So that was kind of how we kind of looked at it and did that, you know, that clear zone plus 10. But yes, that is a safety benefit of corridor consistency and those things. So we'll be monitoring that in-house through our traffic section.
All good points, Tom and Cole. Thank you very much. We do have a couple of other questions in the chat. And Douglas, I see you have your hand up. Let's start with Carolyn's question. How far apart were the sunny and shady sites? And how do the plow drivers select application rates and for what size areas?
So the sun and shade were about half mile apart. The sensors are actually laid across about 5 miles, where we were full sun, mixed, you know, conifers, deciduous. We just kind of picked basically a 5-6 mile corridor, but the full sun and full shade were next to each other and about a half mile apart. And how do they select? So in the trucks, they're given sander controls, and that's calibrated against the transmission, so it knows how fast it's going. So you basically spin your dial from 50 pounds a lane mile up to 800, and then you can hit blast if you hit like a small area where it'll double your treatment. So if you're at 200, you'll hit blast, it'll double it to 400 for a period of time. And like Mihai said, we did have a special sensor put in this truck. It took us a long time to find one that was very precise because we need a GPS location every time that the sander was altered. And so that's what that was doing, is every time they altered the switch, you know, we'll go from like 100 pounds to 300 pounds or something. That's what that triggered. And so, yeah, it's very precise in the trucks. Everything's metered. Our liquid's metered through our system, and then inputted, you know, back through the process of material application. So all our granulars metered, and so it's all done through that sander control, and then it goes to a cloud where Mihai was extracting the data.
Thank you for that. James or Samantha, could you unmute Douglas, please?
I think I already got permission. Can you guys hear me?
Yep.
Can you all hear? Oh, thank you. I just want to start by saying thanks so much, both to the research team for presenting, but also the operations folks for supporting this. Really appreciate what you folks do. My question is related to precipitation conditions. At any point, did you look into what these temperature differences were while snow was flying? And so that's kind of point one. And as an extension to that, we noted it was a low precipitation winter, and you had a 2-to-1 ratio of salt being used or materials being used in your shady section compared to your sunny one. If you had more precip, either time period wise or snow total wise, would you expect that ratio to stay the same or vary? So those are my questions. But again, just thanks everyone.
So I can answer the material, or try to answer that. So I would think it'd be fairly consistent. You know, really temperature, you know, with precip makes that's what we really look at, you know, deciding, you know, I talked about 90-10, so that's 90% sand, 10% salt. And you can see on that one day, it was extremely cold out, but we had an ice condition that had formed, and then we had the temperatures just fall out. So we just used a sand mix to try to grind it off the road per se. But, you know, all the way at the beginning of the presentation where Mihai kind of showed that chart of how much salt can melt a gallon or a pound of ice, it's really exponentially, the warmer it is, the better salt works. So temperature is really what has driving factor on the material, I think. So warmer winter, you could use less salt to do more. So there could be, if it gets extremely cold and we have a lot of precip, then it would drive that factor up even more. The other part was just somebody else remember the other part of that?
Yep. I mean, that's a great question, but I think that requires an entire new project looking at the moisture and the rain. I mean, we are trying to collect this information. I think my colleague, Professor Shefan, can tell you a lot more about this. We are looking also at snowpack, the presence of snow and snowpacking and things like that. But that's a lot of data that needs to be collected, maybe a little bit different sensors and things like that. But very important. Tom mentioned a couple of times, with moisture and shade versus sun, looking at freeze-thaw cycles, for example, and things like that. So, but great question, but I don't think we have an answer right now.
I will say though, we did measure the temperature of the pavement during snow and ice events. That it was a continuous measurement. The sensors ping about every 5 seconds through a Verizon cell phone service, and so they have that data both during an event, after an event, before an event. So and there it's 24/7 coverage on those sensors.
Maybe add on to what Mihai just mentioned, excuse me, with freeze-thaw cycles. Some of these other, like I said, rabbit holes we may go down. There is a issue with if you've got more freeze-thaw cycles, your pavement's moist longer, you've got stripping issues that creates ruts, cracks, and maybe more patching and things like that. So we can compare what this section of roadway looked with historical data when we've measured things in the past to see if there's differences here between the open areas and the shaded areas and see if there's some different things. And then does that equate to maybe more patching, more crack filling, more issues with pavement quality and things like that. So we've got this section of roadway we can look at. There's a section of Highway 113 not too far north of here, or towards the reservation, that would maybe be another good section to look at. That you're trying to paint the full picture here, but there's issues even into the summer seasons with the pavement being more moist, and then the spring and the fall when you've got the freeze thaw cycles hitting us more prevalently, that it's going to affect the pavement. But just how much that might be is kind of be something fun to look at, and just at least pull some of that data and scratch the surface on that stuff a little bit as well.
Okay, we have time for a couple of more questions here. One from Dwayne. Has there been any thought given to how might stem thinning be different from tree topping?
I think that's some of the stuff, Dwayne, maybe that we'll look into. I don't know if Shui would have ideas on that, but you're looking at the mix of the trees and what's out there with the canopy and trying to come up with what's going to make the most sense. And I think those are some of the things that maybe we'd be wrestling with here in the future, is what's the best way to do that. So that's probably still things that the group will be looking at. And I think limbing might be easier if you start lopping off the tops of trees. There's some issues with that potentially. So I would think you maybe would thin and limb and not lop, if that makes sense. But those will be some things we have to look at here more in the future. So good question.
And clarifying question for Cole from Carolyn. Are the plow operators given application rates, or do they choose them themselves?
Well, there's multiple ways that they get fed. So basically, they put in a road condition. It takes into account all the weather data that it has, and it actually puts out a recommendation to the plow operator. That is just a recommendation. They do have the ability to make on-the-call judgment calls in the truck, but it's a recommendation, and we measure the recommended versus actual on each route over the season. So we can do coaching with employees if there's, material usage is too high or too low. So they're given a recommendation, and then they do have in-cab cards that kind of talk about temperature. correlation to how effective salt is and when to not use salt. And then they ultimately have the decision to utilize that, and then we measure against that on an overall season. We don't do storm by storm just because there's so many variables. You just kind of get that overall average.
Okay, and we'll take one or two more questions here. One from Carol. Is there an opportunity to further investigate shade temperature studies from the hot part of the year and pavement life length versus the cost of applying salt to high winter shade versus tree removal costs? So combining all of this, it's certainly probably opportunities for future research after this project.
Yeah, I think so. Yeah, we are hoping for that. And I know that there was another question before that related to heat island effect, urban heat island effect. And I wanted to ask my colleague, Professor Shea Feng, to maybe talk a little bit about that, because that's also a very, very important issue. So.
Yeah, I'm happy to do that. I think some of the models that we've developed here are very useful for thinking about those questions, right? Like there's nothing in the model that says this has to be applied in the wintertime. And in fact, all the first principles that were built in is equally applicable to heat transferring during the summertime as well. And I know that considerations around heat island effect and cooling and shade is actually quite important during that time of the year. And so it's going to be important to think about the trade-offs and the balances associated with all these different benefits and or potential costs for having trees. Like some of those costs Tom has already mentioned in terms of like the shade leading to more chloride impacts that then like gets propagated downstream to water quality concerns. But how we kind of balance those different types of benefits and the different types of costs is something that we're hoping to extend into the future for further analysis.
Okay, well, I think we will move on to start wrapping up today's webinar. I'll pass it back to Beth. Thanks again, everybody.
Thanks, Kristen. Just one more thank you for our speakers, Tom, Miyai, Shui, and San Li. Thank you so much. Really popular topic that engaged the group. So, and we also, I think, came up with a bunch more study topics to spin off of this study. So that's been great. We're going to transition now to a round robin. We still have lots of people on the call here, so don't be shy. I'm going to start with the first question, which is about current infrastructure issues that your organization might be facing. Does anyone have thoughts on that? I guess I can say one thing that I'm in project delivery basically and design, just kind of keeping tabs on what's happening at a federal level. In many ways, there's impacts from a funding standpoint and also like a review and approval process and duration that really is relevant for how quickly we can get out to bid projects and get them under construction. So that's something we're keeping an eye on. And I'm guessing, those changes at that level have different impacts depending on your business. So wondering if anyone else is dealing with those types of issues and uncertainties. No? How about any organizational or informational or event updates to share? Does anyone have any things relevant for the group that might want to be shared in terms of events or organization outings? I am going to put in a plug for the APWA Minnesota chapter. So that's the American Public Works Association. They have their spring conference coming up here May 7th through the 9th. And it's an event up north in Brainerd that is full of opportunities for networking. There's a couple service projects, and then there's presentations that range anywhere from attracting and recruiting in today's job market to lessons learned from projects with large community impact, and all the way to a case study on the Rapidan Dam failure that happened not that long ago. So I'll put information in the chat about that conference in case you're interested in learning more. It's just a couple weeks away. Anybody have anything to add? Our third question is about ideas for potential future council meeting topics or speakers. And like I said, I think we covered a lot of spin-off topics from the topic for today. But if anyone has one, feel free to share it. All right, hearing nothing, I guess we'll call it a day. It's about 20 after 2 here, so enjoy the rest of your Friday afternoon.
Thank you.
Yeah.
Thank you.
Bye.